Hello everyone. Suppose we are presented with the following problem. We are given a spring that is hanging on to some ledge, the ceiling, let's say. So this is a spring that is hanging on to the ceiling, or a ledge for that matter, and there is a weight that we can hang on to the spring. So we can put a weight on there. Let's call that weight W. Last video we saw that you could name the quantities. So let's call that weight W. We don't know what it is yet. We can make it whatever we want. So we've been given a spring, a particular spring, and we hang a weight W on it. Then we know from our daily experience that the spring is going to show some sort of extension. It's going to extend. There's going to be an increase in its length, and the increase, we have a name for that increase. We call it the extension, and let's give that extension the name X. So this extension that the spring experiences due to the weight hanging on there is X, and we are told to investigate how these two quantities change when we change W. So how does X change when we change W? This is an experimental fact that if the spring that is given to you is good enough, it is a good enough spring. In other words, it is a stiff enough spring that it does not deform very easily. That if you hang on to it some weight W, it's going to show some extension X. But if you change W, if you make W twice as large, so suppose I make here a table now of W and X, okay? So this is in let's say grams, and this is in centimeters. So when I hang on there a weight of 10 grams, let's say, it shows me it gives me an extension of 2 centimeters, let's say. Then we will observe, it is an experimental fact, that if you double the weight hanging on to this spring, the extension is going to double. In other words, if the spring is good enough, and if we are carrying out this experiment very carefully, and we make our measurements very carefully, then if we double the weight, suppose we make it 20 grams, then the extension is also going to double. It's going to double, so it's going to go from 2 to 4. If we triple it, if we hang on there 30 grams, then this is also going to triple. It's going to show 6 centimeters extension. And we can go on and on like this. If we make it 4 times as large, it's going to become, the extension is also going to become 4 times as large. And this now, you should actually relate this situation with the previous situation of when we had a ratio. We said when we had a ratio A is to B, we said that we had a ratio A is to B, it is equivalent. This ratio is actually equivalent in some sense. It is telling us the exact same thing as just M times A to M times B. We can write this, in other words, A over B is the same as M times A over M times B. What this tells us is that if you multiply both the numerator and the denominator of a fraction by the same number, you get a new fraction which is actually equivalent to the one which we had previously. Now you should relate the two situations. You can see now that this ratio 10 over 2 is fixed, that if you double this quantity also doubles. If you make this quantity only half as large, so if I hang only 5 grams on there, this is going to become only half as large as well. This is going to be only 1 centimeters then, 1 centimeter. And you can actually watch another video on this same channel. I will put a link to that video in the description of this one, where you can actually see how a spring behaves when you hang on there some weight. And you can actually, because that video includes a little Java applet that you can play with as well. It's really fun to play with that Java applet, and I highly suggest that you watch that video if you are more interested in this. So this now, this is there something special then about this situation where if you double one quantity, the other doubles as well? Well, yes, there is something special, because we say if such a situation arises between two quantities, we make the following definition. We say that W and X are directly proportional. Directly proportional. Oops, I don't want that. Directly proportional. Let me write this somewhere else. So let me write it here. W and X are in direct proportion. We make this very important definition. So I'll repeat it once more. So when our two quantities are in direct proportion? When are two quantities in direct proportion? Exactly when, if you double one quantity, the other doubles as well. If you triple one, the other triples as well. Or another way of saying the same thing is that the ratio of the two quantities is fixed. In other words, 10 over 2 is the same as 20 over 4, is the same as 30 over 6, is the same as 5 over 1. In other words, the ratio in which the two quantities occur does not change. It is fixed. Normally when we talk about direct proportion, if someone asks us what is direct proportion, we say that, well, the direct proportion is when if you increase one quantity, the other increases. That is not a very, although that is correct, that is not a very complete thing to say, because there is another condition on direct proportion, in that if you multiply one quantity by some number, the other one gets multiplied by the same number as well. So here I gave you this situation whereby you had a spring and a weight hanging onto the spring, and we saw that if you doubled the weight, the extension doubled. If you tripled the weight, the extension tripled. Well, we did not see it, but I just told you that it happens. You'll have to conduct experiments to actually find out that what I told you is true, and you will find that it is true. Unless you hang on there some very crazy weight which deforms the spring, in which case it no longer holds true. But generally this holds true for all good springs. So this definition then is useful for us because this occurs in the universe all the time. This relationship between two quantities, the direct proportion relationship, is then something that occurs again and again when we study the universe. I'll give you an example. This is perhaps the simplest example that you and I can always relate to. So a little notation here, that if two quantities are in direct proportion, we write them out like this. W is directly proportional to X. So this reads as W is directly proportional to X. W is directly proportional to X. This is also read as W changes as X changes. So this relationship, let's see another example of this. Suppose you are driving a car. So here you are driving a car, and the road on which you're driving is completely straight. There are no bends, there are no traffic signals, you don't have to stop anywhere, it's completely empty, and you're going at a certain speed. You're always traveling at the same speed, you don't change the speed. So suppose that the speed at which this car can go is fixed, and it's going on this road, and you're driving it. Let's make a table of the distance that it covers, let's call the distance d, and the time that you drive. So if you drive for 1 hour, let's say, it might go some distance. It might go a distance, well, it really depends on what speed you're going by. So if you're going at, say, 60 kilometers per hour, then it's going to go at, it's going to go only 60 kilometers far. Then in 2 hours, it's going to go 120 kilometers. In 3 hours, it's going to go 180 kilometers. And in only half an hour, it's going to go only 30 kilometers. So you see these two quantities, distance and time, provided that the speed is held constant while you're driving in this direction, is these two quantities are then in direct proportion. So this then, let's just generalize this idea. Let's just generalize this idea and write it in a more useful form. So I'm going to write this down now for you in a form that will help us actually solve problems involving these proportions. So if I write down A is directly proportional to B, then this statement tells me the exact same thing as saying that A over B is fixed. It is fixed. We just saw two cases in which this is true. Well, it is true in all cases. So if A and B are in direct proportion, then A over B is fixed. It is one number. No matter how you change A or B, if you change either one of these quantities, the other is going to adjust itself so that the ratio is always fixed. And this is direct proportion. And this is always going to help us solve problems involving direct proportion. Believe me. So I think I will stop here, and in the next video we'll talk about inverse proportion, which is exactly the same thing as direct proportion, except you have to make only a slight adjustment. And we'll see that we can actually distill inverse proportion into a similar statement, into this kind of statement, which is going to help us solve problems. So right now what we concluded was that if two quantities are in direct proportion, the ratio is fixed. So I'll see you in the next video.